Hi, this is a video to go over Algebra 1, Lesson 4.4, and we will be talking about the line of best fit. So this video is not anything additional, just either watch the video or read through the notes. It's your choice. So by the end of this lesson, you'll be able to write the equation for the line of best fit. So that's what we're kind of going to be learning to do. When we do a line of best fit, we'll want it to correlate the most with that data, and we can use that formula that we come up with to make predictions. Okay, so let's look here. We've got these three different graphs, and we're going to talk about correlation and line of best fit. So we talked about in the previous lesson using data points of two variables to create a scatter plot. So like we see below, so that we could kind of see what the data looks like. Okay, gives us a view. And we learned there are three different types of relationships. So we can see the positive correlation here. Okay, we've got the negative correlation in the middle and no correlation on the right. So if you look at the positive correlation, it's a graph with, if we drew a line through it, it'd be a positive slope. And so one way I think about it is that's the way you want your money to go, or anyway, that's a positive slope. The next one in the middle is a negative correlation. If we drew a line through that, that would have a negative slope. And then the last one is no correlation because we just have a bunch of random dots. Okay, let's go ahead. We're not gonna watch the slope-intercept form video, but maybe I'll post a video that we can look at that. I guess let's just read what it says here. So linear equations are oftentimes written in the form y equals mx plus b. This is the slope-intercept form, and this is what we will be using for today's lesson, where m represents the slope of the line or the rate of change, and b represents the y-intercept. And if you remember, the y-intercept is the place that the line crosses the y-axis. Okay, so let's look at making a line of best fit. Okay, so we're going to use everything we've learned and kind of put that together so we can make basically a prediction of this data, just a line that kind of sums it all up. So let's say we have this data, we have our months. So we have 0, 1, 2, 3, 4, 5, 6. And then we have different times. So I don't know exactly what this is for, but we have months and different times. So month 0, 40, month 1, 38, month 2, 35, month 3, 33. So if we plot this, what kind of correlation do you think this has? Just looking at this, this is a good time. You can pause the video if you want and think about it. Is it going to be a positive correlation, a negative correlation, or no correlation? Well, on this one, we can see if we drew a line right here, we'd have a line right through these points, somewhere like this. We can see this is a negative correlation. We're going down over time. And so, yeah, this graph would be a negative correlation. Okay. All right. So we're going to work on finding an equation of this data as we go on. So let's first, little refresher, calculating slope. We can use the slope formula y2 minus y1 over x2 minus x1. And that formula will find us the slope. Now, if you remember, those are going to be just two ordered pairs that we substitute in. And so we'll look at doing that below. Okay, so we still have this data. And so in this section 1, we're going to be looking for the line of best fit for the following data points. Okay, so first we plot the data and we draw the fitted line. So I kind of did that before. It looks like they did it here. So we could just draw a line through the data. And this is just kind of your best guess. I would say right where they did it works. It's through most, we can see it's kind of in the middle of most of the points. All of the points are close to that. So that's just a best fit line. When you draw a best fit line, it doesn't have to be perfect. There's going to be slightly different interpretations. As long as you're not drawing something like this for a best fit line, you're good. You want it something that's through the points, okay? So we're going to find 2 points. And once we, and I guess this is explaining that. So once you've drawn the line, we want to look for 2 data points that are most centered on the line. You may not have 2 points on the line at all, but we use the closest or most centered points to the line. Okay, so on this one, it looks like they chose, we have a point right here, and that looks like it's the 235 that you see written here. So that's one of the points chosen. And then the other point it looks like is 528. We can see this line passes right through that. So here, this is the point 528. And so that's this point right here. And so we have those 2 points. And so we're going to use those to come up with the equation, excuse me, of the line. Okay, so let's kind of keep looking. So we've got our 2 points. Now, once we have our 2 points, we're going to find the slope formula. So one way to think of this is, so let's write our 2 points. We have 235 and 528. Those are the 2 points we're estimating are the best for this line to go through. So if you remember, x1 is, we'll call 2, y1 we'll call 35. So you can call either point the first point or the second point. You just want to be consistent. So we have x2 and y2. And so now we're going to go ahead and find the slope. And they do this right down here, but I'll just show you what's going on. So if we do y2 minus y1, we'll go 28 minus 35 over x2 minus x1, so 5 minus 2. And so we'll get, in the numerator, 28 minus 35, we get a negative 7. 5 minus 2, we get a positive 3. And so this is going to be the slope of our best fit line. Now it's negative, we notice it's negative, and that's how it should be. It should be a negative slope because it's going through those points. Okay, let's keep looking through here. So we came up with the negative 7/3. So because now that we have the slope, if you remember, now we're going to use one of these 2 points as to help us in this point slope equation. Okay, and we'll just use the same point they did. It doesn't matter. You could use either of the 2 points to find your equation. But here, since they use 235, let's go ahead and do that. So we have 235. We have slope m equals negative 7/3. And so let's go ahead and we're going to substitute this in. So again, we can think of 2 as x1. We can think of 35 as y1. So we'll have y minus y1, which is 35, equals m. So I'm using that point slope formula. So equals negative 7/3 times x minus x1, which is 2. Now we're going to simplify this out. So we have y minus 35. I want to distribute this in. So I'll have equals negative 7/3 x plus, now if we take this out to the side, it's kind of like negative 7/3 times negative 2, or the same thing would be negative 2 over 1. So negative 7 times negative 2 would give me a positive 14. 3 times 1 gives me a 3. And so that's where they're getting this 14/3 right here. Okay, so we have a positive 14/3 there. Now we want to add 35 to both sides. Pause for just a second. You'll see, if you look down here at this step, you'll see that there's a mistake. So this is correct, negative 7/3 times x. But here we ended up with an extra negative here. So there's really just the negative 7/3 times negative 2, but we ended up with an extra negative. So I'm just going to make that a plus. So we'd have negative 7 times negative 2, which would give us plus 14/3. So just make note of that. Hopefully by the time this video comes out, it might be fixed, but just in case it's not, it should be a plus 14/3. Okay, let's go back to ours above here that we're doing. So we added 35 to both sides because we want to isolate the y, because just like we talked about at the beginning, we want our final equation to be y equals mx plus b. We want it to be in this form. So we add 35 to both sides. Now similarly, we can take this 14/3 plus 35. We can take this over here and make it into a common denominator. So we see the denominator is 3. So let's go ahead and multiply the top and bottom by 3 because we can't add fractions unless they have the same denominator. If you do this on a calculator, that's fantastic, but we'll just see how to do it this way. So we have 35 times 3 is going to be 105. So 105 over 3. If we add 14 and 105, we're going to get 119. So we'll have 119 over 3. So then our final answer is we still have y equals negative 7/3 x. When we added these two together, that's where we got our 119 over 3. And so this would be the equation of this best fit line that we had above. Okay, so let's just scroll up and look at that. So that's the equation for this line is that y equals negative 7/3 x plus 119 thirds. So you can see there is going to be a mistake down. Oh, it got fixed. Tell me how it got fixed here. It's fine. So, okay, so even though in this step it looks like it's still negative 14 thirds, luckily though, it did get fixed, so it was a positive 14 thirds plus 35 does equal 119 thirds. And then if you want to write it as a mixed number like this, I think that's more correct on this type of problem, but I would accept either answer. So that would be the best fit line. So basically it's the same thing we were doing before, but this time you find the 2 points and then you find the slope between the 2 points. And then you'll use that slope with one of the points use point slope equation to find the equation of the line in slope intercept form. So, okay, let's keep looking what we have here. So I'll let you watch these videos. Make sure you do watch these videos. I am not covering any of the content there and you're still responsible for that. And they're really great videos. So make sure to watch those. Okay, let's look at section 2, making predictions. Okay, so now we have our equation of the line of best fit. And so we're going to use this equation to make prediction based on the data that we had before. So now we're seeing what that table was about. So what the table represented is after X number of months, how long it would take to run a 5K race. And so you can see if you look above, it made sense that as they ran longer and more months of training, that their time went down for the 5K race. So that's what that table represented. So these values, the months, represent the domain of the equation. So X values always represent the domain. In this case, it was the passage of time or the passage of the months. But what if we want to know how long to expect the race to take if someone has trained for 8 months or 10 months or 12 months? And so what is awesome is that equation that we just found, we can use that to predict how many months it will take. Okay, so for example, predict the time it would take to run a 5K after 8 months of training. Well, if you remember, we said that the 8 stands for X. That's the domain, and those are the X values. And so we can just substitute it in, and you'll see this over here, but if you want to see it written out, we'll do this. So negative 7/3 times 8 plus 119 over 3, or it's the same as 39 2/3. And so then we can just work this out. Negative 7/3 times 8, it's really like 8 over 1. So we'll get negative 56/3. I'm actually going to change this to 119 thirds. So we add those together and they end up as 63 thirds, which is so lucky because 63 divided by 3 equals 21. So what that tells us is if someone has trained for 8 months, we would expect the race to take them 21 minutes. Okay, so it's helpful to know what the X stands for and what the Y stands for. Okay, I'm going to start a new video because this one's about to run out of time.